So welcome everybody to the Astro Cafe for Monday, February the 3rd. This is the first, last, and only Astro Cafe for February for for reasons that will become apparent as we proceed through with the announcements. Um, Got kind of an interesting and focused Astro Cafe primarily on the southern hemisphere skies. Um, I just once more will ask before I start, is there anybody who wants me to slot them in? Is there anybody who has anything that they want to bring up other than the folks that have spoken? Okay. Well, if anything occurs, please bring it up because we'll have time to do that. I'm going to just do slide share to or screen share to start. Okay, so is that if people see that, does it come up as a night sky in Chile? Yeah,
Yeah,
give me a thumbs up or something, somebody. Yeah,
yes,
good. Okay, perfect. So I had the opportunity in January to do a 3-week trip to Chile. It was mostly kayaking in southern Chile, and had a couple of opportunities to have a look at the sky. So I'm going to walk you through a couple of the geographic anomalies I ran into, and then we'll get down to some of the views of the sky, and some of the other stories. And there's a few Easter eggs that come up along the way. So Chile, as I'm sure everybody's aware, is in the southern hemisphere, so the west coast of South America. Um, Interesting, when you think about South America from a north hemisphere perspective, you sort of think of the hemisphere divided. The hemisphere is divided north and south, and uh, Chile is from pretty far down south. But it's interesting how much South America, is closer to the equator than North America. Chile itself lies between latitudes of about 17 degrees and 56 degrees south. It's about 4,200 kilometers long and quite narrow. The northern border at 17 degrees is about the same latitude as St. Kitts in the Caribbean, or interestingly, the border of North and South of Vietnam. Tierra del Fuego in the south at about 56 degrees south, which is, the tip of the continent, is actually on the same latitude as Moscow or South Alaska, the peninsula of Alaska, or Hudson's Hope in north central British Columbia. One of the things that I found interesting, in my northocentric perspective of Chile was that as I prepared for the trip, I realized that going from the west coast of Canada to the west coast of South America, there was actually a 5-hour time difference, which was striking until I actually looked at a map. Now, part of the time difference is because we have seasons separate. We're in the winter, Chile's in the summer, and vice versa. But still, if you look at the map, Chile really lies more on line with Atlantic Canada, not with Western Canada. We landed in the capital, Santiago, spent a few days there, and then went out to the coast of Valparaiso. Valparaiso is kind of an interesting city of about 900,000 in the metro of Valparaiso, right on the water. It's an artist community and a very unique center because it was built through immigration from Germany and England and Spain, and it's represented by all kinds of different communities. It Valparaiso is at about 33 degrees, so it's on line with Dallas and Santiago and Nagasaki and Baghdad. So Valparaiso. is located right down here, about the center of Chile. Um, the hostel we were in had a roof bar, and we were up there one night, and Venus and Saturn, and actually on the other side of the sky, Mars were all up at the same time. I got this shot. As you can see, it's really kind of pretty light polluted. But this shot of Venus and Saturn, the shot I did of Mars was just wiped out and really wasn't that interesting. This is I do correlate shots with my Sky Safari just to verify the position and the location. From Valparaiso, we flew down to the area where we started the kayak trip, which was putting it at Puerto Aysén, and then using a kayaking off a boat to go through the federal park system through sort of south central Chile. This was the boat that we were on. As it turned out, there were six kayakers on it, and we, kayaked through this area down to the San Rafael Glacier, which is a glacier that you can access as a tidewater glacier. So it's calving into the San Rafael Lagoon here. Sa San Rafael Lagoon is at about 46 degrees south latitude, which puts it compared to the northern hemisphere at around the level of Odessa in Ukraine or Manitoulin Island in Ontario or St. Pierre, the island of St. Pierre in the St. Lawrence. The San Rafael Glacier, as I said, is at the southern end of the trip. Everybody has something famous for or claims fame for what they have. The San Rafael Glacier is actually is the tidewater glacier which is closest to the equator in the world. So all others are further away from the equator. It's quite interesting, quite beautiful with the calving and the bergs that are floating in the lagoon. Um, following following paddling here, we went back up the channel and put in just north of San Rafael Glacier, which is where the story really starts. We did a night paddle. It was with an absolutely clear night. Started out at dusk and returned in pitch black to the boat. Fortunately, we found the boat. Got back on, and then the guide for the trip had done some celestial navigation. He'd actually done a term at the university on board a tall ship, so he was quite interested in stars and celestial navigation. So we climbed up onto the top deck and just had a look. Fortunately, and this was not planned, of course, the moon was quite bright, and it was a waning gibbous moon, but it didn't come up until about midnight, just before midnight. So we were up and looking before the moon came up. First view in the southeastern sky, of course, was the Southern Cross. Southern Cross is right here, and the Southern Cross is oriented now pointing up at about 45 degrees. Southern Cross is found from the two pointer stars, Alpha Centauri and Beta Centauri, and just follow them along, and you'll find the Southern Cross. One other thing to point out, because it's going to be pertinent later in the story, is that there's a dark nebula in this area, which is either referred to as the Coalsack or the Coalsack Nebula. It shows up as just a dark area against the Milky Way coming right down through the Southern Cross. Again, this is the Sky Safari correlate showing the Southern Cross here and the two pointer stars. I took out the background just so that you'd have, a look at just the stars themselves again, the pointer stars, the Southern Cross.
And what's up above that, Jeff?
That's a very good question, and I'm glad you asked it because we're going to have a much more learned view of the
Okay.
Southern Cross, and we're going to have I'm sure, in-depth explanation of that. Right, Joe? Yes.
Yes, I
Um,
think so.
Actually, I should stop. Is there anybody else who can point out some of the other? I don't know a lot about the Southern stars. Lauri, do you know, or does anybody want to point out anything here? I'm afraid I'm the only one with the pointer.
Which one is Sirius?
No, a very good question. Sirius would be about here. I
Be about
think
there. Okay.
I think this is Sirius, but I'm not positive because everything is as you know, it's got a little bit of a comma. But that would be the position of Sirius, Lori.
Okay. No, I don't know that part of the sky really at all.
Okay. Well, we will have another chance to have a look at it with a much better photograph in a little while, Lori.
Jeff, is that
Of
where
course.
Sirius is? Is that
I'm
where the
sorry.
zenith was?
I'm
Was that directly overhead in this
Oh,
image?
sorry, is this where the zenith was?
Yeah.
Interesting. I would have said not, but it's certainly high up in the sky. Let's just go back and see because I took this at the same time.
Mhm.
Here's Sirius. I wouldn't have said that was really.
So beyond that would be Orion, right? Just above
Yeah.
it. Okay.
We'll get there in a sec, Dave, because that's
Okay.
that's slightly different part of the sky. But yes, you're right. I mean,
Jeff,
Orion would
Jeff,
be
I don't know
pointing to.
whether Jeffy, I don't know whether you'd see it. Natasha's wondering if you can make the pictures a little bit bigger. I don't know whether you can, or whether you can make them larger.
Very good question. Can I expand it on this screen? I don't think so, Natasha. I'm sorry. Rather than expanding it, it just advances. Um, yeah. Are you okay? This was for a different presentation, so it's the same thing. One thing, maybe this is a little bit bigger view of at least the Southern Cross. One thing I wanted to point out, and I mentioned this last time I talked about the Southern Cross. The way you can find due south from the Southern Cross is to take a line along the long axis, go 4 times that distance, and then drop down to the horizon. So that should give you due south. Or they say a more accurate way is to take a line between the two pointer stars, midpoint, take a 90-degree angle up, and where that intersects the line drawn between the major axis or the long axis of the cross, you then drop that down. That's supposed to be slightly more accurate, but obviously a little bit more difficult. So go ahead, whoever's talking.
I said there's at least some advantage in the night sky in the northern hemisphere.
With Polaris, you mean?
Yeah,
Yeah.
everybody always says how much better the southern sky is, but at least we have a star we can align with.
Okay. So this was the northern sky. This is so I'll start it. It was completely disorienting to me because I'm used to seeing Orion in the southern sky. Orion was in the northern sky, and from the northocentric view I had, Orion was standing on its head. Betelgeuse here, Rigel here. If you're looking for Sirius, it would actually be off here. And if you come down this way, it's actually a lovely view of Taurus, and Aldebaran being Alpha Tauri. And this anomalous star is Jupiter. And then if you carry right down through Taurus, I mean, we were turned around. We were trying to figure out what this group of stars was, and of course, it's the Pleiades cluster.
The interesting thing is the guys in the south, they look at Orion upside down and the belt stars and whatnot, which is the bottom of Orion. Down there, they call the pot with the handle.
Interesting. I mean, there would of course be a different interpretation. None of them being right. Um, one interesting thing, when I was reading, Aldebaran is of course an Arabic name, and it means the follower. And so why is it called the follower? It's called the follower because it follows the Pleiades cluster across the sky. So again, just the correlate with that. So the real reason I wanted to look in the southern sky, and it's in the southwest sky, is the Magellanic Clouds, because I'd never seen them before. I hope this is coming out well. True to form. They're kind of wispy and hazy, to just the eye, the Greater Magellanic Cloud and the Lesser Magellanic Cloud.
Jeff, are these extended exposures to even see them like that?
These are my iPhone shooting in night mode.
Oh, okay.
Yeah. No, so no, I can't claim much in the way of sort of expert settings for night viewing. This was freezing cold on top of the boat after paddling for 3 hours. So uh,
They are pretty bright though.
oh well, it was fantastic, and you'll see some better views of it. You'll see some way better views of it in a few minutes. But anyway, it was so really interesting. I've been looking forward to seeing these all my life, and I actually did some further reading about them. So I just wanted to talk about the Magellanic Clouds for a minute.
Did you have a chance to use binoculars?
I didn't, not at all.
Too bad. Okay.
Yeah, it is, in retrospect, what should I have done? Of course, taking binoculars up would have been great. And in fact, the Magellanic Clouds, we now know is a small galaxy or dwarf galaxy, close to the Milky Way, but you can actually resolve individual stars. Um, so Magellanic Clouds were named after, of course, Ferdinand Magellan in his circumnavigation 1519 to 1522. His crew had documented seeing these cloud-like formations in the southern sky during the trip. The difficulty is that he set off with 5 ships and 270 crewmen. He was killed in the Philippines. 18 of his crew returned in one ship. So a lot of records were lost. There was one guy who was still doing quite a bit of recording. So that's where they have some of the information about his trip. I mean, he certainly didn't discover the Magellanic Clouds. It's seen in Persian literature, Portuguese and Dutch sailing records, lots of stories through native mythology, the Maori in New Zealand, Polynesian natives, the Aborigines in Australia, and as you see, some of the native tribes in southern Chile all mentioned the Magellanic Clouds. Anybody who's recorded it, though, agrees that it's mostly visible, almost solely in the southern hemisphere or very close to the equator. The name actually didn't get fixed for about 100 years. After Magellan came back, I mean, I guess there was lots of legends about his trip, and the term Magellanic Clouds was used certainly by sailors, for the next 100 years, but it didn't really occur in the literature, as a fixed name for those dwarf galaxies until about 1679. Interestingly, because of that, because it was known to a lot of native groups previous to Magellan, there is some agitation that I came across in astronomic circles with articles from 2020 up to 2024 suggesting that the name should be changed. But whether or not that's going to happen, we'll have to see. They next became, well known because Henrietta Leavitt focused her observations on the Magellanic Clouds. Her paper in 1908 was titled 1,777 Variables in the Magellanic Clouds. Then she began looking seriously at the luminosity and period relationship in the Cepheid variables. And her paper in 1912 was the period of 25 variable stars in the small Magellanic Cloud. In just looking into some stuff for talking about it tonight, I actually ran across an online copy of her 1912 paper. I threw it up, if anybody's interested. It makes, it's an interesting read, and her chart's quite interesting. So this is the reference to it. Interestingly, this was put online because of some work that was being done on The Silent Sky, which was the play that was at the Belfry Theatre a few years ago. So following Henrietta Leavitt, looking at the period luminosity, Einar Hertzsprung in 1913 and then Harlow Shapley in 1918 used recalibrations of the period luminosity relationship to try to estimate the distance to the Magellanic Clouds. It's interesting because at the time that they were doing the estimate, the Milky Way was still thought to be the only game in town, and thought to define the known universe. Whether that was the overriding factor or whether it was just the rough calculations used with the Cepheids. Hertzsprung's calculation in 1912 put the Magellanic Clouds at 30,000 light years. Shapley a few years later, and with again revision of the relationship, the period luminosity relationship, put the estimate at 69,000 and 78,000 light years, both quite short of the real distance, as you'll see. It was after Hubble, really demonstrated that the universe was a lot larger because of his work with spectroscopes and redshifts, that people started looking again at the distance to the Magellanic Clouds. Interesting, from the recent Astronomy magazine, there's some suggesting that Vesto Slipher actually identified that relationship sooner than Hubble did, or that is the expansion of the universe. But again, we'll see if much comes of that. So what do we know about the Magellanic Clouds now? There are two small satellite galaxies, the Milky Way galaxy. The small Magellanic Cloud is put at about 200,000 light years away. Large Magellanic Cloud at about 160,000 light years away. They're about 75,000 light years distance from each other. The Large Magellanic Cloud is about 14,000 light years across, or it subtends an arc of about 5 degrees in the sky. Small Magellanic Cloud is about 7,000 light years across, with an arc of 2 degrees in the sky. Differing from the Milky Way, they're quite rich in hydrogen and helium, so they're thought to be active star-forming regions. The structure of the Magellanic Clouds, they appear to be irregular galaxies, but there's a lot of suggestion that they really do have a central bar structure, and so that they're spiral galaxies, but it's been the gravitational forces from the Milky Way being so close that's distorted that shape and made them appear to be irregular galaxies. Quick review of that. It was Hubble's tuning fork that suggested the morphologic structure of galaxies being either elliptical or lenticular, or spiral. So either spiral without a bar or spiral with a bar. So the Magellanic Clouds are thought to have been spiral with a bar and distorted by gravitational forces. They're members of the local group of galaxies. They're very close to the Milky Way. In fact, they're among the closest to the Milky Way galaxy. The local group is a group of about 30 plus. In fact, I've seen estimates up to 80 galaxies spread over about 10 million light years. Milky Way and Andromeda and the Andromeda galaxies are the largest galaxies in the local group. This is a good quick graphic I found just of the local group. It's actually not comprehensive because there's a larger circle encompassing some of the more distant galaxies in the local group. But you can see that if you look at the center and expand that, you get the Magellanic Clouds then, at about 200,000, 160,000 light years distant from the center, which in this case is the Milky Way galaxy. So the best legend that I thought existed that I came across of the Magellanic Clouds or talking about them came from the Mapuche native tribe, which is a group in southern Chile. They're sort of the bad boys of Chile. They're a very independent group. They resisted the Inca and stayed independent when the Inca were there. They resisted the Spaniards and stayed independent when the Spaniards swept through. And they continue to resist the government. So they really have established their territory. Their territory is just north of where I was paddling in the Lake District of southern Chile. So anyway, their legend about the Magellanic Clouds. There are 3 ponds in the sky. The first pond, which is thought to have been the Coalsack Nebula, that dark area around the Southern Cross, has dried out. The second pond in the sky, the small Magellanic Cloud, is on its way to drying out. When that's dried out, then the last pond, the large Magellanic Cloud, will start to dry out. And when it becomes empty, that will be the end of the universe. So on that cheery and positive note, I'll end my discussion of the skies and entertain any questions if anybody wants to raise any points or questions. Okay.
That looks just fabulous, Jeff. Oh my gosh. Was it really cold?
So Valparaiso and Santiago were like 32 degrees because it's the middle of their
Okay.
summer. Um, the area around the glacier was cold. It's more the wind in Patagonia. Often quite windy. It was rainy for probably a third of the days we were paddling. Temperature, coldest was probably 5 degrees, and the warmest was probably 12 degrees. So, it wasn't bad. I mean, we certainly wore a bunch of layers. A lot of fun. I'll tell you, I've been paddling on the gorge since coming back, and the water in the gorge is colder than the water, in
Yeah.
Patagonia, right by the
Wow.
San Rafael Glacier. So I guess everything's relative. Water can't get colder than I think about 34 degrees Fahrenheit.
Well, it looks
So
gorgeous.
we have another really interesting presentation. Let me just cancel this one. Are you all set, Joe, if I put that up?
Sure.
Okay, good. So Joe, I put up the New Zealand slides first. Let me just put this as a slideshow.
Okay.
They were just wonderful slides, and perhaps you could sort of introduce them and talk. As I told you, I've got a map of New Zealand to start.
Okay. You can show that if you want.
Okay, do you see that? Okay.
Not yet. Not yet.
Oh dear. Oh dear. Okay, because I'm looking at it. Okay.
I think you shut your share off.
Oh dear. Oh, maybe that's what I need to do. Go back to share. Okay. Well, let me exit out of this one. There you guys. Yeah, you're right. Sorry about that. You see a map now?
Yep.
Okay. You're looking at a map of New Zealand.
Good. Well, this trip happened a long time ago, back in 2010. John and Wendy McDonald and myself traveled to New Zealand. Actually, we sailed there in a cruise ship. But we spent some time in New Zealand, and we just didn't have a huge amount of time. We had just a little over, I think we had 2 weeks. So we stuck to the North Island. And we stuck to the north part of the North Island, actually.
I'm sure.
So Auckland, you can see Auckland where Jeff's pointer is there. We just went up as far as Whangarei, which is halfway up that way. And then we went down as far as roughly Taupo, which is near Rotorua and the famous stinky pools and volcanic activity area and that sort of thing. So,
While you have the map up, Joe.
Pardon me?
While you have the map up, point out Hamilton. That's going to be what Dave's going to be talking about.
He is, yeah. I don't see Hamilton on there, but it's down
right under Island, the North Island.
Oh, there it is. Okay.
Right here.
Yep.
There you go.
Yep.
Yeah.
This is pretty small scale map. That's okay.
Where's Mordor?
Mordor is to South Hamilton.
Oh, okay.
We actually visited that area, but that's not part of this talk.
Yeah. He was looking the other direction, I think.
Yeah, Hobbiton was about 10 miles from Hamilton.
Yeah.
Okay, interesting.
Oh,
So,
well.
can I move? Tell me when you want
Yeah.
me to move the slide.
Yeah, you
Joe.
can go to the next slide. I'm sort of glancing back and forth, forgive me, but I'm referring to notes because this was such a long time ago. So John took these set of photos from Kerry, which is just sort of a half day's drive north from Auckland. It's a rural area, and but as you can see, there is some urban development in there. By and large, New Zealand, just for reference sake, has a lot of agricultural areas, a lot of sheep and crops and that sort of thing. So it's a fairly dark country as far as astronomy is concerned. I mean, other than the big cities, it's a great place to see the night sky. This obviously is taken just as dawn is disappearing. And from Kerry is a pretty small town, 10, 20,000 people sort of thing. You can have a look there on the right-hand side near just above the clouds, and you will see the Southern Cross pointing downward. If you go down further, right down there, yeah, that's the Southern Cross there.
These are the pointer stars, I assume?
Yeah.
That's the Free Medicine Story, that's the cross?
Yeah.
Okay.
You can go to the next slide. A little bit easier to see things on this one. I'll just change my slide too so I can keep going.
Down here. Oh, this must be oh, there it is. Yeah. So that's the cross.
Yep, you can see the cross right near the horizon this time. It's sinking down a little bit. And again, the pointer stars, but if you glance over to the left, you'll see the Magellanic, one of the Magellanic clouds.
Mm-hmm.
Is this perhaps both?
Yeah, it's both of them. That's again, it's not very impressive at the moment, but it's kind of a nice star field.
That's
And if you
beautiful.
have a look at these by linking directly to the gallery, which I'll link to in the notes, you'll be able to get a better view than what we're seeing through the video. There's quite a bit of star detail. Did you want to jump in, Dave?
My first experience with that was we went down to New Zealand the first time in 1998. My wife had an opportunity to go with her colleague to Antarctica. So we met her in Hamilton and then did a little quick tour up the north of the island, a little bit north of Kerikeri, near the Bay of Islands. And I went out my first chance with binoculars to look at the southern sky, and it was partly cloudy. I was laying on my back on a picnic table, and I was looking through holes, and I saw what I thought was the Large Magellanic Cloud until the sky cleared a little bit. And I realized what I was looking at was 47 Tucana, which is a huge globular cluster in that Large Magellanic Cloud. And to see the entire thing, I had to rock my binoculars back and forth about 2 degrees. It's big, and it's
that cluster certainly blows away M13 any day.
Yeah,
especially in binoculars.
Yeah.
You can go to the next slide, Dave. Yeah. I think you skipped a slide, or
this is the order it's in, perhaps.
Okay, that's fine. That's fine. Yeah, so here we go with the Magellanic Clouds. John certainly has a much better image here than a much darker sky. And you can see there's a huge amount of activity going on, especially in the Large Magellanic Cloud on the bottom of the frame. But they're both absolutely stunning in binoculars or an image.
You guys, or perhaps it's John, has a fantastic detail of the photo that was done, and I don't recall that, but can you identify what sort of how this was taken, what sort of power?
Yeah, this is probably one of John's first deep sky images using his new setup at the time, which was a travel tracking mount, and his Canon T1i. I think it was it's a modified camera, yeah, and just using a kit lens, 17 to 50 millimeter lens. So he was running that at 35 millimeters to get this wider field. We were both using AstroTrack tracking mounts, which are travel mounts you can mount on top of a reasonably sturdy tripod and put a camera on, or even a small telescope for that matter. But these were all taken with consumer lenses.
And these are single photos, right? Not stacked photos.
No, these would be stacked. In this case, it was stacked 14 frames, 30 seconds each.
Okay.
And he was kind of pushing it at 3200 ISO. So, but he did take some dark frames to help tame some of the noise, because this is a fairly early Canon camera, but it was certainly a huge step forward for folks like us who didn't want to spend 5 figures on an astronomy camera, which you couldn't really travel with anyway. So this was a big step forward. Yeah.
Well, there you go.
There we go. Now we've got the southern Milky Way. And this is from Warkworth, New Zealand, which is just between Kerikeri and Auckland, actually. So there's a bit more sky glow, as you can see, but still beautiful. Dark lanes, lots and lots of detail in the Milky Way itself, with nebula and lots of glowing gas around there. I'm not going to go through every thing in that frame because it would take a whole evening.
I'll move you through quickly, Joe.
Yeah, there's the sky map, which is the handy thing. I'm glad you put that up. So yeah, Sagittarius is there, which we're familiar with, and M8, M17, M16. We can see M6, all those sort of things. But this is really high up in the sky, so it absolutely is gorgeous to observe and photograph. Obviously,
I guess as a point of reference for people, if you are at Cattle Point during the summer, the teapot is actually at the horizon line. It's very, very low down. So you're seeing like the bottom third isn't even visible here, or not very well.
And I should also mention this was October 26, 2010. So this was our fall, their spring. That makes a huge difference as to the orientation of things.
Oh,
okay. So where are we at? Okay, LMC's next.
Yeah. You can see the
isn't that
structure.
just amazing amount of detail there? Yeah. So 14,000 light years across and 160,000 light years from us, according to John, and about a tenth the mass of the Milky Way. So it's quite small. Go to the next one if you want.
This is Orion.
Oh, there we are. Yeah. I'm looking at two screens. Sorry.
Sorry, can you point it out? Where's the belt? Right there.
The belt?
Right in the middle.
I think this,
the belt is right in the middle.
Oh, right.
That's the sword. Yeah.
And Orion's head is pointing downward.
Okay. Yep.
Yeah. So Betelgeuse is at the bottom.
Betelgeuse here?
Yep.
So
right?
those four bright stars in the trapezoid, and the sword is what they call a pot and kettle in New Zealand.
Yeah.
Potted kettle.
Pot and kettle.
Pot and kettle.
So it is upside down again. Yeah.
Yeah.
Oh yeah.
Pot and handle. The sword is the handle of the pot.
Oh, I see it.
Okay.
As you say, Jeff, it's very disorienting when you're down there. I really recommend either you get a Southern Sky Atlas printed or a planisphere from the Southern Hemisphere is even better. You don't really need a huge amount of detail because you'll just get lost anyway. So you're better off with a planisphere so you can at least have half a chance of finding the major stuff.
Yeah, I think what Joe's saying is that you kind of need to see the whole view at once, because if you just look at a little chunk of it, the rest of it's going to be wrong, right? So you're going to be thinking the wrong way. So you really need to see the whole view first.
So you can't star hop when everything's in the opposite direction,
no,
or the opposite orientation.
Right.
And the moon is upside down and backwards.
Oh yeah. I actually like the fact that the horns are facing downwards. It's kind of cool, actually.
So is this serious?
Yes.
Yep.
Okay.
Yeah.
Okay.
And the top right star is Rigel.
Rigel would be here?
Yes.
Yeah.
Did you think it was a joke? Sorry.
Is that a constellation?
It's serious.
That's something a lot of people are saying these days. Is that serious?
No kidding. Okay, this is a fisheye view that John took, basically, of the whole sky. And really, it's just to show off the Magellanic Clouds. This was taken from Lake Okareka, which is near Rotorua. It's a nice dark area. And we stayed at, just a side note, we stayed at Lake Okareka because the guest house we stayed at claimed that it was clear of all the smell. Because if you stay in Rotorua, you know right away where you're at, because it's
well, you
have all these these mud pools that are belching sulfuric fumes all the time.
Well, you kind of almost don't notice it after the second or third day.
Yeah, once the hairs inside your nose are all burned off, yeah.
Rotten Rua, they call it.
Yep.
Yeah. So anyway,
Joe,
yes,
sorry, could you go back? Is that little kind of the Australis corona? Is that right down in that bottom right-hand corner? There's that like that nice little, yeah, just right there.
I think you're right. Yeah. Yeah, there's a did we see the
Yeah.
star chart yet? Let's go to the star chart, which is, if you can, Jeff.
Is
There
this
we go.
Ah, there we go. Okay.
Okay. That
Thank
help a
you.
little bit?
That's it.
Yeah.
Oh, there it is. Yeah.
You were bang
Yeah.
on,
Yeah.
Lauri.
Yeah.
Yeah.
There it is.
And
I
that,
don't remember seeing that when I was down south. I do not remember seeing that
well,
corona.
it'll depend on what month you were down there, of course.
Yeah, I guess so.
Mhm.
Yeah.
Yeah. Anyway,
Oh, that's good catch, Lauri. No, that's really neat.
I
It's
see
Jupiter,
patterns like
okay.
that.
I
So
see. That's Jupiter. Okay.
Yeah, Jupiter. I love this one because it really tells you what's going on in the southern polar area. If you look there with this star trail photograph, you can see right away that there are no stars at the southern celestial pole, or they're very, very faint. So that is really the conundrum when you're down there if you're trying to set up a equatorial mount. What do you align on?
Yeah, I guess you're better off with a compass, in fact, and then
Yeah,
test,
well,
right?
you use pointer stars, and the AstroTrack tracking mount actually comes with reticles for the south,
Mhm.
and you line up pointer stars, two sets of pointer stars. So basically, that gets you very close. But there's really nothing to observe like Polaris is, like we have with Polaris in the north. It only has a half degree eccentricity. So around the pole. So
What
down
you
there
would
you've got a very dark area of the sky is the southern
what you
celestial
wouldn't
pole.
have given for plate solving.
Yeah.
Yeah. This
I,
was old school where you actually
I,
had to
Yeah.
look through
I just had a barn door tracker, and my southern sky polar finder was a fellow by the name of Dave Brock, and
There
I
you
put
go.
him on the eyepiece of a finder scope and say, "Dave, point it in the right direction."
Yeah,
Yeah.
you need young eyes, right?
I'm sorry, can I go back? Or you can even do it with this one. Which direction are those stars going? Like I'm in the north and I look up, then things are going like in one like from the east to the west. And I know kind
Clockwise
of
or
which direction to look at.
counterclockwise?
What are they doing here?
I
They're
think
going
it,
east to west, but if you're facing south,
I think it doesn't matter which hemisphere.
yeah,
They go east to west, I
east to go
think.
west. But if you're facing south, it'll go from left to right, whereas in north, it's
Yeah,
right to
of
left.
course.
You beat me to it, Dave.
Okay.
It's
Okay.
still disorienting, as you will know.
Oh yeah.
Yes.
Yeah.
Absolutely disorienting.
Yeah, we know they go from east to west, but you're looking in
Yes.
a different perspective on the
Yeah.
on the whole celestial sphere. Yeah. It's a lot of fun.
That's beautiful.
Yeah, isn't it?
And if you're looking north and trying to identify something, what I used to do is turn around, bend over backwards, and then I could recognize things.
Oh well, if you can do that, yeah.
Mm.
So that's the deck from
Yeah.
from New Zealand.
Yeah, that's New Zealand. So Jeff's going to show us something a little bit more weird now because these were taken in Costa Rica. Costa Rica, if you pop up the map, is about where we were staying was the Gulf of Nicoya, which you can see right above the Central America tag. So we were staying just in the sort of the mid to northern coast, Pacific coast of Costa Rica. We were in a ranch farm, which we took over. They also ran a lodge, and this was actually a tour put on by Travel Quest for astronomy, amateur astronomers. So we got to see stuff that was happening, current stuff that was happening, things like comets. So Lulin was up there, and I got some great views of that. As you can see, I got a pretty good photograph of it as well. Comet Lulin is C 2007 N3 Lulin. This was, keep in mind, this was taken in February 2009. Costa Rica's on Central Time, about 8:20 p.m. And also saw this through a 15-inch Dob, which just blew me away. Some guy from Calgary had a 15-inch Dob shipped down to Costa Rica, and he hauled it to the our observing field. And what a treat that was, being in such a dark sky. Okay, let's go to the next one, Jeff. This was a kind of a cool alignment, and it was Gary Saronic. Some of you will know Gary Saronic. He was a local astronomer here for a while, and then he's sort of moved around. He writes for Sky and Telescope. He's the guy who wrote the binocular atlas, I guess it's called. I don't know what it's called, that Sky and Telescope publishes. Probably they still do. Now, in this shot,
there it is. Yeah.
you can see, I don't know if you can see it. If you will be able to see it on Zenfolio, but this video is really washing it out. But yeah, Jeff's pointing it out. That is Mercury.
Right. That's beautiful.
Yeah. And the crescent moon. We thought we were going to get skunked this night, but I just went out there and did it anyway. And sure enough, I managed to grab one. And then Jupiter and Mars were in a conjunction up above. So that was a really nice planetary setup.
Yeah, it's nice.
With the crescent moon. And
yeah.
So when I've been a photographer all my life, and I rate my photographs from 1 star to 5 star. And 1 star is useless. 2 stars is usable. 3 stars is sort of average. 4 stars is excellent, and 5 star are one in a lifetime. And so that's when I rated it 5 stars, because it just has it all. And so the crux, the Southern Cross, is on the left. This is just for reference sake. This is taken with a Canon zoom lens running at 70 millimeters, and I was using a modified Canon digital SLR on that tracker I talked about earlier. So I managed to get quite a few frames that night, and even though it was very warm, the camera was creating a lot of noise, the sensor. I managed to tune most of it out with some dark frames. So you can see there the 5 stars of the Southern Cross. The diffusion in this photograph really worked to my advantage, because it really shows off the star colors beautifully. And you can see that 5th star there is very red, orangey red color. this part of the sky is just something. When you have binoculars on this part of the sky, you could just sit there for hours because there's so much going on in the Milky Way in this area. So from left to right, the Southern Cross, the red nebula in the lower center area is IC 2944. Stock 13 clusters above it. It's sort of a not too spectacular open cluster. And then the Etecrina Nebula is, of course, on the right. And below it is the Southern Pleiades, so-called. And above the Etecrina is the jewel box to the left there, Jeff. To the left,
Here.
right there. Yeah.
Okay.
Mm-hmm. Yeah,
so
the geobox is absolutely amazing in binos.
Yeah,
it's so pretty.
So many different colors of stars in that cluster. It's just something else. Yeah.
Tell me about the Southern Pleiades. It's an open cluster?
It is. Yep. Yeah,
And
they appear to all be the same color, just like the Pleiades that we see. Don't quote me on their age, though. I couldn't tell you.
okay. Okay.
They look a little whiter in this photograph than the Pleiades do, but I don't know. I'm sure someone can look it up and find out. Yeah, so I guess the point is with this, even though we're 10 degrees north of the equator, if you go down there in February or March, you can see quite a bit of the southern hemisphere from there. You can see one of the Magellanic Clouds, not both of them, from there at the right time of year. So it's kind of a nice way to take about an 8-hour flights to Costa Rica instead of a 20-hour flight to New Zealand or Australia, or Chile for that matter.
Can you estimate what altitude that's at? Like how high above the horizon?
That was very close to the horizon. Yeah, it was. I don't have it in my notes, but there would be maybe 2 photographic frames below this, and then the horizon. So pretty close. Pretty, not great.
Yeah, from someplace like Barbados, it would be pretty low on the horizon.
Yeah.
That's a great picture.
Yeah, I mean, you can even go. Sorry?
I was just say that's a beautiful picture, Joe.
Mm-hmm.
Yeah,
just gorgeous. Yeah.
One of those ones that just works.
Mm-hmm.
Good. Any other questions of Joe or comments? Okay, thank you very much, Joe. I really appreciate you putting that presentation together. That's great. We put references to it because this is all in Zenfolio, and this is
It is, yes.
just spectacular.
Yeah, we have them in collections on Zenfolio, so I'll put that in the notes.
Good, thanks.
And I added Gary Saronic's Binocular Highlights. That's what his book is called.
So if you ever have a chance to get across the equator, by all means do it. And you don't necessarily have to take a telescope and a camera and all that sort of stuff. You can do it with binoculars. Good set of 7x50s are just perfect for an evening's observing.
So Randy, we've been talking about the disorientation in the southern hemisphere. You had a presentation with an upside down compass.
I do indeed. Okay. So I have this presentation. Okay, yeah, I was down in 2014 in very far south in Argentina, in Patagonia, in a village right near the border with Chile called El Chalten, which is mostly filled with German adventurers. There's a list out there of 10 places on this earth that you have to go to that all the young Germans follow. And so the place is just crawling with Germans and with mountain climbers. You can see why the mountain climbers go there. So the Andes were to our west, and we were doing our geophysics, our paleomagnetic work to the east. So everybody is there to go further west from this little town, and we're always driving the other direction. And I just want to show you a bit what I do as a paleomagnetist. Paleomagnetism, studying ancient magnetism. And in this case, we were interested to know the ages of these volcanic rocks because it was related to glaciations, and we wanted to see the difference in timing between northern and southern glaciations. Anyway, I'm not going to go into that. It's a whole other thing. But we want to know the direction of magnetism stored in these rocks. And so first of all, we have a converted chainsaw and a little rock corer with diamond bit. So we can take these little bits of rock, but we have to know their orientation. So that's René Berendret from University of Lethbridge up there. And here I am. And we put a tube into the hole that we drilled, and then we have a compass on it. And the goal is to get these little cores. They're 2.5 centimeters diameter and about 6-8 centimeters long. And they've got this marking on it, that arrow, which we have to orient. What is its azimuth? What direction is it with respect to north? And what is its plunge? How steep is it against the horizontal? Okay, so here's a close-up. So again, here is one of the holes that we haven't yet pulled out. Okay, and here's one where we put the tube in, and then we level it. And this is a compass. And I'm going to just talk about a compass a bit. And for the 4 people who braved the snow and came here, compasses, magnetic compasses, also have a trouble in the southern hemisphere for a completely different reason. The Earth's magnetic field, it points to the north, but that's only part of the direction. That's its horizontal component. There's also a dip to the magnetic field. Here in Victoria, it's very steep. It's about 70 degrees down. There's more vertical component than there is horizontal component. And when you buy a northern hemisphere compass, it's weighted. This southern part of the needle is weighted so that it doesn't bang against the glass. So I'm going to pass this around to the people here. But if you were to take your compass to the southern hemisphere, it would be tilted and would bang against the glass, and you have to keep tapping it. It's irritating. Or you have to put a little bit of copper wire around the northern part of the needle so that it weighs it down. Anyway, that's a whole other thing. The Earth's magnetic field points down in the northern hemisphere and it points up in the southern hemisphere. Okay, it always points to the north, but the vertical component is different. But we're not talking about that. What we're going to talk about is this gizmo on top, and that's called a sun compass. Now I brought one. Let's just see if it makes sense. If I have to turn off. Can you see this, or is it too small? Maybe after the show I'll do this again. But for now, I'll just pass it around in here.
Oh, Randy,
Yeah.
do it again. I pinned you, so it makes it big.
Oh, but I think that's only pinned for you, not for everybody.
Oh, is that true?
Yeah.
No, keep moving. Stop. There you go. Can everybody see that?
Stop talking, David.
Oh,
And
Wait,
Randy
wait.
needs to talk, get the focus
Oh.
back.
Oh,
Anyway,
yeah. Okay, got it.
Oh, well.
I
So
will,
much for coaching.
I will show it to you later. Anyway,
Okay.
so let's just talk about where the sun goes. It rises in the east and sets in the west. So far, so good. So here is a picture. There are mountains there. So this is a sunset because it's flat to the east where we were, and it's very mountainous to the west. Okay, so that's normal. Okay, doesn't matter where you are in the world, the east, the sun rises. But at noon, and this is the thing that's just so freaky, is the sun goes through the north instead of through the south. And it's disorienting. That's all I can say. It's just weird. But that's where it does it. And so here's a close-up of a sun compass. And it's a sundial. It's a plain sundial. And you have a plane which you set to be the angle of the latitude. Okay, so let's see. It would be if you're at the North Pole, it would be horizontal. So it's the you set it flat if you're at the North Pole, and because the sun's going to go around you. Whereas at the equator, you would set the plane vertical. The white plane in this picture is set so that it will be parallel to the equator, and the gnomon, the line coming out of the middle, is going to be parallel with the Earth's pole if it is pointing north. So the trick is, with the sundial, you usually get out your compass, get the declination right, and you set it in concrete, and it stays there. And you look at the shadow, and it tells you the time. We do it the other way around. You set the shadow so it's at the right time, and then the arrow is going to point north. Okay, so it's backwards, but it's the same idea. Okay, so in this case, we see the shadow. Well, if you had the shadow coming straight down the gnomon, that's noon, and it would only show that if the n were pointing to 0. Does that make sense? In this case, it is 1, 2, 3, 4. It's about 4:10 in the afternoon, and the north is about 18 degrees east of north. Not the arrow. The arrow is north. This line here. So you align this edge with whatever you're trying to get the direction of, and it is going to be 18 degrees. You see 10, 20, 30. So there's 18 degrees. This line here is 18 degrees east of north. Okay? So here's another way of looking at it. If you are at latitude phi, and if you align it towards the north, then the sun is going to go around that gnomon, that pointer, 15 degrees an hour, or it takes 4 minutes for every degree. Does that make sense? So yeah, if you want 1 degree accuracy, you only have to be able to read the time of that shadow to within 4 minutes, which is not difficult with that with this dial. Okay, but this shadow of that pointer there, which is parallel with the rotational pole of the Earth, the sun is going to go around that 15 degrees every hour. So then you have to set the time, and you don't go by the radio and say, it's 10 in the morning, because you need to know local time. So there is a nice simple equation. So first of all, you take civil time, get it from the radio or whatever, and then every degree of longitude from the reference longitude for your time zone is going to be 4 minutes. So in our case, we're at 123.3 degrees west. So we're 3.3 degrees from 120, which is the reference longitude for Pacific time. If we were in mountain time, it would be 105 degrees, but we're at 120. And so 4 times 3.3, well, 4 times 3 is 12, and then it's another 13 degrees, 13 minutes. Okay, so civil time minus 13 minutes, and then we have the equation of time. So this is how much the solar time leads or lags the average time for the whole year. And this is the same all over the world. And it has to do with the Earth's orbit not being circular. It's an ellipse. And so it is closer to the sun in the winter. And so the Earth is zipping along and the days are longer. And so the sundial gets further and further behind January, February. So we're at the very latest. We're at about 14 minutes lag because of the rotation of the Earth around the sun not being constant. Okay, so the time here in Victoria is 27 minutes, like in February, is 27 minutes off noon. And if you cheat and pull up SunCalc or the equivalent, then you see indeed it's 1716. Now on the screen here in the room, it's flipped off the side, which is unfortunate, but I can assure you, no, not 1716. It's 12:27 is noon. It's 27 minutes off. Can you see that at home? I don't know whether it clips for you guys also.
Yes, we can see it.
Okay, great. Anyway, so now with fancy apps in your pocket, you don't have to go through all of this, but you know, I've been doing this for 40 years and we didn't have apps for the most of my career. Okay, so I just told you how we use it up here in the Northern Hemisphere, where I've done all my work for 40 years, except for this 3-week trip to Patagonia, where we held our sun compass upside down, or we held it right side up, but we were upside down, or whatever. Anyway, the problem is the sundial, we're looking at it from the other side. So in the Northern Hemisphere, the shadow is going to go from the morning, 6 in the morning, here's 11 in the morning, noon, 1 in the afternoon, and we read where the north is. But when it's upside down, then we didn't actually mark up the camera, you just do it and you check that you did it right, because you get confused every time, but you have to read the clock backwards. So this is like 7:50 in the morning, going towards noon and then going to the afternoon. And you have to add 180 degrees to the direction. So you see 0 turns into 180, 30 turns into 210, but 330, you don't add 180, you subtract 180. And it turns out to be the same thing because 360 degrees in the circle. You get used to doing adding and subtracting by 180 in your head real quick. Anyway, that's how you use a sundial when you're standing on your head. And here's a nice sunrise over Mount Fitzroy, which is one of the great peaks on the Chile-Argentine border, and named after the captain of Darwin's ship, the Beagle, because they took a break and they went for a walk inland and they came here. And of course, it's called Cerro Chaltez in Spanish, because they don't need to have some Anglo-Saxon name on it. But it's mostly known as Cerro Fitzroy. And that's my
Did
story.
you see that yourself, or is that a stock?
Oh, no. I took a really bad picture at the same time that my friend with his very nice camera took this picture.
Wow.
This is Brian Menounos' picture, but I was right beside him taking with my little camera the same scene. So that's the Belt of Venus, or the Alpenglow on the mountains.
Well, check off your bucket list on that one.
Oh, and the peak on the left, called Cerro Torre, it's notorious for mountain climbers. It actually was never, nobody got to the peak until 2002, and many people have died trying. It is not a nice place to go up. And I think only like 5 people have ever been up there. On the far left. The one on the far left is the one that's impossible to climb. Okay, so I'm going to unshare. And then I'm going to ask Alex to pin me. So go to the 3 little dots. And pin to first screen, I guess. Okay, great. And here we go. Woo, there we go. So what we have here is, first of all, you set, a bit fuzzy, isn't it? Anyway, you set the plane so that it's at the right latitude. So in this case, 49 degrees. And then the vertical, the perpendicular to the plane is what you're looking at, the shadow. The triangle is just to hold it up. You don't just put a pin there, because this is a piece of field equipment and it gets banged around a lot. But you set it, you see there's a level. So this has to be level. And the thing that you are measuring, whatever, you know, for me, the direction that we drilled the core is the direction of the arrow, and then you turn this until the shadow is set to the right time, or the anti-time if you're in the southern hemisphere. And then you read the direction with the arrow, but then you have to add or subtract 180 if you're in the southern hemisphere. It's a lovely piece of equipment. Very robust. This particular one was built probably 50 years ago. We have about 4 of them, but they never have to be replaced. It's a lovely tool. Okay.
Beautiful.
What would the accuracy be of that compass?
Oh, between 1 and 2 degrees. It really depends if you have a good shadow or not. If it's a sunny, clear sunny day, then you can see what time it is to within a couple of minutes, no problem. So that's half a degree.
Remove pin top left.
If it's a fuzzy,
Top left. Ah, okay.
if it's a fuzzy day, then sometimes it's hard to see exactly where the shadow is. But it's important when you're looking at highly magnetized rocks like we were looking at, those were basalts, and a magnetic compass gets deviated by the magnetism of the rocks that we're looking at. So the sun compass is much more accurate when the rocks that you're collecting are very magnetic.
Interesting. Thank you, Randy. Appreciate that. Dave, did you have some information you wanted to share about your time in New Zealand?
Yeah, just a quick run through. Our first trip to New Zealand was in 1998. My wife, Julia, is a petroleum microbiologist, ex-professor at the U of A. And she has a colleague in Hamilton, New Zealand, who does the same kind of work. And her name's Jackie Aisleby. And she invited Julia to go down to Antarctica to sample some oil spill sites in Antarctica. So that was our first trip down. And while we were down there and getting ready to come back, Jackie says, well, you know, Julia, you have a sabbatical coming up. Why don't you come to New Zealand and do it here? So in 2000, from 2000 to 2001, me and my wife and daughter went and lived in New Zealand for a year in Hamilton. I got to know the guys in the local astronomy club really well. They were one of the first groups that I contacted before we went down. And I asked them if they had a loaner telescope I could borrow, or if, and they said, no, if you've got your optics, bring them down. We got a guy here, Dave Brock, who will help you rebuild it in a Dobsonian mount. So I did. I ended up selling that telescope to one of the club members down there when I came back to Edmonton, and so it still lives in New Zealand. So I told them, being so kind, I would give them a talk on observing in the north. So I scrounged a whole bunch of slides and stuff from observing in the Edmonton area. And I went to the meeting and gave them a little 15, 20-minute talk and showed them slides. And afterwards, they extracted $40 New Zealand from me to join the club. And the next day, they had me out with a public observing session outside the observatory, trying to show people around the night sky I was totally unfamiliar with. They're just wonderful people. It was so easy to become part of the community down there. So if you have a chance to go to New Zealand, by all means, take it. It's an amazing place. The geology and geography are quite different from what we experience around here. The North Island is quite different from the South Island. There's lots of things to see and do. And the people are just absolutely outstanding and friendly. We had a lot of wonderful experiences. One of my favorite places in New Zealand was just north of Auckland at Muriwai Beach. And this is a beach on the Tasman side that's about 60 miles of sand beach. And right at the south end of that beach is Muriwai. And at Muriwai, there's an onshore gannet colony. And this is the art piece my wife did from photographs taken at Muriwai Beach of these South Ocean gannets that are almost within touching distance. Huge colony of them. It's just an absolutely gorgeous place. So if you have a chance to go down there, by all means do it. And if you're going, get in touch with either Auckland or Hamilton, and there's one also in a club also in Christchurch. Get in touch with them ahead of time. They usually have websites available because people are particularly generous, and they will show you around the night sky.
Wonderful.
Dave?
Yeah.
There are many people who say they like the southern sky more than the northern sky. Why?
Oh, depends on where you are, I guess, but certainly from Hamilton, you're looking at this just the southern part of the Milky Way, which has a lot more objects in it. And 47 Tucana and the LMC and the SMC. Like I say, I was laying on my back on this picnic table and I was looking, and I thought I was looking at the LMC, and it turned out it was 47 Tuc. And to see the LMC, I had to actually rock the binoculars back and forth. It's such a large object. And in a lot of places in New Zealand and in not the main cities in Australia, the skies are dark. There's small communities everywhere. And if you can get away from the sea a little bit where the skies are not as moist, you get a really good view of the southern sky.
I think the other thing is the objects are brighter, or they appear to be, like Centaurus
Yeah.
AB. Centaurus is very bright.
Yeah.
I can't remember which double I saw down in the southern hemisphere, but I had my small 70 millimeter refractor with me, and I remember looking at them, and I just couldn't believe my eyes. They looked like two headlights in the refractor. They're super bright.
Well, that section of the Milky Way from Sagittarius down through Norma and the Crux is just, you could spend days just observing through there.
Well, they're looking at the inside of the
Yeah.
Milky Way, and we're looking at the
At the outside. Yeah.
That's the other way of thinking of it.
That's
Yeah.
And that's the huge difference. Why they
a
have
lot
so
more
many-
nebulosity.
Yeah.
Yeah. It's just, looking into Carina is really, you could spend hours just moosing around through Carina with your binoculars. Yeah.
And then the Magellanic Clouds are a bonus on top of that.
Yeah.
Thank you, Dave.
Yeah.
Margie, you had a question you wanted to raise?
I do. Researching again. So my question is, how is the Plaskett mirror cleaned? I have done a little bit of research about cleaning both small mirrors and large mirrors, and distilled water and air gun and cleaning solution and cotton come up. Can somebody tell me how the Plaskett mirror is actually cleaned when it's taken out of the telescope?
Yeah, I think that's a feat in itself, actually. I think it's, I think Jim is here, or somebody can tell me, because I'm not certain. But I think there's an opening in the floor, and it's actually dropped through down to that
David?
lower area.
David, I know how it gets down to
Oh,
the.
okay.
I don't know what happens when it's on the platform. I don't know the cleaning process for sure.
Yeah, I can't tell you that.
Okay.
Maybe Jim can tell us. I'm sure Jim can tell us.
Wire brushes.
Wire brushes. You're banned.
No, Jim is not within hearing distance.
Yeah. It's not like cleaning my own mirror in the 10-inch where I just put it in the sink and run water on it, and no soap or nothing like that. Just get it nice and warm water and get it wet. And then let it stand vertical to dry. And then you get a little thing called a Kim wipe, which is a tissue that is lint-free or plant fiber-free. And you just touch every little drop of water on that surface. And the last rinse, you put a little bit of just one drop of rinse aid in, so that it sheets off rather than just bubbling off.
Yeah.
I'm about due to do that, because one of the things it'll do, it'll remove the little Sharpie marks that I have that mark the center of the mirror, and I need that to do collimation. So I have to figure out how to spin the mirror around on a turntable so that I can put a little dot right in the middle.
Yes, and so
I know.
Lauri.
Yeah, I know a little bit. I'm not sure who else is on Who else is online here tonight?
Bill would,
Uh,
but he's come and gone.
okay. When they take the mirror out and they put it in that flat, in the big flat piece, they do have to take off all of the coating that is on there. They take off the coating. Now, exactly how that is done, I'm not sure, but I have a feeling it's done with some sort of air compression.
Mm.
Some like a something that is kind of just taking it off. I'm not sure, but I'll tell you something in a minute that might help that. And then when that's all completely done and the whole thing is all clear, then they stand it back up again. So it's horizontal, and that whole table just simply comes up and flips up to the vertical, and they open up that great big huge
Gee.
oh
Machine.
Vacuum chamber. Vacuum chamber. Yeah.
and then it goes in there, and then they have to completely take out, of course they take out all the air out of there, and then they spray the aluminum very, very, very tiny, with tiny hole. They spray the aluminum over the mirror, and it's so small. I was trying to get it from Dimitri Monin how much it was, and I think, if I'm correct, it's 3 nanometers is
Yeah.
what the the depth of what they do. And it all is triggered, is completely triggered within the whole thing, so that as soon as it gets to be exactly the right amount, like it stops, like it's all like automatically set. And then they take it back out again, and then it's lifted back up and put back into back in upstairs. Now, on the Center of the Universe website, there is a video that has been made the last time. I don't know whether you've seen it, but the last time that they did this, which was during the pandemic, was at one point, because I know everybody has to have masks on anyway, but even more.
Lauri,
Yes.
I have it queued up.
Oh, have you got it queued up?
I have it queued up. So, Jeff, do we have time, you think?
It's about 4 minutes, Jeff.
Yeah, go for it. Go for it,
Okay,
guys.
here we
Okay.
go. I have to.
Yeah, it's great. I've seen it. Yeah.
So they don't just clean it, they actually re-illuminize it then.
Yes,
They
yes,
protect it.
completely.
Yeah.
Yeah. Listen to the great music.
The music is not going to come through well.
Oh, okay.
But can you talk about what's going on?
Well, I mean, they're up there unscrewing all the parts around there. This whole thing
2021, it said.
Oh, okay. Yeah. So just right in the middle of the pandemic. So everything's completely unscrewed, and then the whole thing is just taken out. So the whole thing is now, there's the mirror. They're inspecting it. And who knows what else they're doing. And there comes the crane.
Yep.
Looks really dirty.
Whole thing's taken out and then put through there. So there's the hole that's completely taken out. And now it's in the tray that's on the bottom level. If you go in the bottom level, now you see they're that's what I'm not sure exactly what was on there.
Shaving cream.
Shaving cream.
Oh, there we go. Maybe. Yeah. They're inside the
Cleaning it.
so that's pulled down, then the whole thing is put back in. So you can really see how the shine, like the whole shine has just been completely taken off of it entirely.
Can I join in the discussion?
Yeah.
Please.
I used to work in a factory that were doing DVDs, and we had glass plates with metal coating on it, and we used to dissolve the metal with acid, sulfuric acid.
Okay.
So we
So
would
there's
spray.
the
Those are the nozzles.
the
The no-
Oh
nozzles
yeah, and then yeah,
that are put in.
Aluminum. They have the aluminum in them.
yeah,
Doesn't
and then
take very long.
So
it's a high vacuum chamber, and the aluminum actually vaporizes, and it
Yeah.
condenses back on the mirror.
that's right. Yeah.
So now you can see that it's all shiny again.
Yeah, it's all vapor deposition.
And Margie, the actual cleaning, it looked like it was chemical. I didn't see anybody with their cotton swabs or anything. It looked like they put on that foam and then they rinsed it off.
Yeah. Yeah.
All the aluminum was gone.
Yes, that makes sense because when there's some information online about the Canada, France, Hawaii telescope, and they were it's an article about how they thought they were going to do it, how they thought they were going to clean it the first time, and the words, as I said, air gun, cleaning solution, and cotton, all came up. So I believe it has to be cleaned first, and then the aluminum is taken off it.
Yes. Yeah.
That makes sense because it looked really filthy when it came out. The Plaskett mirror.
Mhm.
There were great big splotches on it.
Yeah. Well,
Sorry, Carlos, you were going to, I don't think you finished before I interrupted you.
You have to unmute, Carlos.
Well, for me?
Yeah.
No.
Yeah, I was asking Carlos, okay, I mean,
So
What-
CJ,
what was-
did you finish
was
what
the-
you were going to say?
Question was whether you had finished your explanation.
Oh yeah, no, I just participate, yeah, because we would clean the aluminum with the acid, and then we would also instead of using distilled water, use isopropyl alcohol, because isopropyl alcohol is one of the rare alcohol that doesn't leave traces when it evaporates.
Yep.
So we would get all the dust and everything out of without even touching with swabs or cotton or anything. Would be pure air. So we had a special micro filter at the end of the pressure nozzle of the compressed air. Then we would just blow, and it would be in clean rooms. But yeah, so there's ways of cleaning a mirror without even touching it.
It was the acid used initially for cleaning the dirt. I missed where that step.
No, the acid was to dissolve the metal.
Oh, it was still right. Okay.
Yeah. So
It's
we
not
would
metal
have
itself.
the aluminum later on in the process, but we would have a mix of silver and nickel, and then we would have a like a highly low pressure chamber like this, the 10 to the power of -6 bar, and that means that by heating up the silver, it would evaporates and then it would condense. So the vapor just goes into the chamber and then condense on the mirror, and by regulating the current through a little tray and the heating process and the time, then you set up the thickness of the layer deposition. And yeah.
Interesting. Thank you.
so Margie, I will find out for you what the solution, or what it is that they use.
Okay, great.
Dimitri Monin would know that. It needs to be done like if it was 2021, it probably will have to be done again this year. It's about every 2, 3, 4 years, depending on what's going on. They just finished doing the 1.2 mirror. So that was all done. So now they're going to have to go back. It takes almost a week to do all of what they just did there. It was about a week.
Yeah. I asked because I'm very fortunately now being able to give a Plaskett Dome tour every whenever the star party is. And so I've put together a series of notes, and sometimes I need to know background information, so then I may or may not tell, I may just simply tell people that the mirror is cleaned and aluminized, but I do take them around to that section. And so if you get a question, then you want to know a little bit more. And that was my other question, is what do you call the name of that machine in which the aluminum nozzles are placing the aluminum onto the mirror? And somebody said vacuum chamber, so
It's an autoclave.
thank you.
Yeah, yeah. I think they call it an aluminizer on the at the center.
Okay.
But what I just find that just what's fascinating is I mean, that machine is, 110 years old or more. And it's been used, before they used to have to do it every several months because the silver would degrade way more than the aluminum will. So they had to do it a lot. So it would have been taken out of commission and all done completely with pulley systems. Like, I mean, no large cranes and, things wandering at all. Everything would have been done completely with pulley systems. And Plaskett figured all that out and how to get it up and down through the floor and all with the pulley systems all there. And that was all done in like 24, I mean, we're like 1914, 1915 when he was designing the telescope. So I'm always just impressed by all the work that was done and how old some of this material is, some of the things that are in the building. Yeah.
And when you're standing there looking at the platform on which the mirror is brought onto, and then just ahead of that is the autoclave. If you look in between them on the left wall, there are two objects there, and what are they? They're part of the old pulley system.
Wow.
For moving the dome. Yeah, they're moving for that's part of the dome movements. Yeah. Oh, I know. Yeah.
Thanks, Lauri.
It's cool.
Thanks for bringing that up. David wanted to bring something up. We're just getting closer to the end time.
Myself or David Payne?
Dave Payne, actually.
Dave Payne. Okay.
I'll come to you next.
Muted.
Nice.
I'll be really brief here. So I just posted another image to Zenfolio. This is of M74, and this is the last of my pre-winter clear sky images that I've been able to process. But it's kind of small, but might have a bigger picture of it. It's a classic look at a galaxy because it's a normal grand design spiral galaxy, but it's also not severely bright. So while it's small, you can get a good look right down to the core of the dust lanes and everything. But I call all this stuff the jewelry of a galaxy. And really what boils down to is hydrogen gas in a spiral going around a central gravitational attractor, like a black hole or something like that. And as I've been going through you may be aware that I've been posting a lot of additional information with my images, going into some of the technical background. And with a lot of help from Joe Carr, I've put together a website. Put together a website that I'm linking my images. So if you go to Zenfolio, it should link back to here. But I'm going through an explanation using fundamental scientific knowledge of how a spiral galaxy is put together, why it's spiral. As an example, I've got another series I'm going to load on here as to how a star actually forms. Because there's always parts of it in the public literature that don't quite make sense. And I think it's either being oversimplified for our consumption, or it's not really well understood in itself. So I'm taking a stab at explaining how these things happen. Two of the things I've just put together have to do with the galactic spiral structure and how that comes about. And to give you an example, there's a bit of a write-up with an explanation. In this case, I'm basically debunking something called the shell theory of gravity. And it's been used to explain a lot of things, but it actually explains nothing. But give an explanation. So if you're a little bit technically minded, you might appreciate that. And then, part two, I go into a little bit more detail as to how spiral galaxy comes together and how its fundamental shape is that of a torus or a donut, and why that is. And I kind of leave it at that. I sometimes include a video. This one was kind of interesting because it shows a black hole taking apart a star, and how it vaporizes a star, it turns into a bunch of gas, and how that gas forms a torus around the black hole. And so I go into how this all works. If you're a bit of an egghead, if you're not, you can skim it. If you are, you can get into some of the details of how gravity works around a torus and that sort of thing. And I'm just writing part 3 now, which is how galaxy gets its spiral arms and that sort of thing. So I put a link in the chat to the website, but you can also get it off of my Zenfolio portfolio. And leave me a comment and have a read when you've got a minute if you're interested in that sort of stuff, and let me know what you think.
Wonderful.
That's great.
Yeah, that is neat. And just to reiterate, the link is posted in the chat.
Yeah, in some future, I'll put together a little talk that summarizes it for Cafe. But
wonderful.
Maybe that could become a book someday.
Might be.
Well, that's why I encourage Dave to write it down on a web page, because it being a little more dynamic than a book, it can be updated and enhanced and added to if he comes across new material or whatever.
Yeah, no, that's a good point.
Dave, it said access to aprealspace.com was denied.
APRealspace.com denied?
That's what my screen says. I don't have authorization to view this page.
No, I've got into it.
They let me in.
Auto photography and interpretation.
Okay.
I got in as well.
Good.
So did I.
Sorry, I put your name on the list. I didn't want you looking at it.
Yeah. You're excluded, unfortunately.
I'll try another time.
Assuming I would know how to do that.
Yeah. That's great, Dave. Thank you.
Thanks.
Dave Lee, you had something you wanted to bring up?
Yes. Just a reminder for beginners. I don't know if everybody who's new here, if you wish to join the beginners, you should let somebody know this evening in the room at Fairfield, and they will let you know my email address, and we'll make sure you get the Zoom link. We start at 7:30 tomorrow evening. So yeah, just let me know if you're not already on the list. I don't see anybody new, so I think we're probably okay.
Super. Well, thank you.
I'll jump into that, David.
Oh, you're not on the list then, Ben?
Not for that one. I'm on the one. I think I've been put on the one to actually go up to the center and
Oh, yeah. Okay,
Saturday nights.
I'll add you. So my email address is david@victoria.rasc.ca. If you just send me a note, and then I'll have your email address.
Okay, so just David and then the normal Victoria address.
Yeah.
Yeah. Okay, thanks.
Thanks.
Super. Lauri, you wanted to say something about the dinner?
Yes, and Marjie, help me out here. The dinner, I hope everybody that's here is going to be able to come to our dinner on the 24th, which is 3 weeks from today. And so at the 4 Mile Pub, and it's Marjie who's taking names. So although I mean I threw her another name today of somebody who emailed me. So as long as you tell somebody that you want to come to the dinner, then we'll get Marjie to put your name on the list. How many people are there, Marjie?
29 so far.
29?
Need more.
What's
Okay.
the critical number? Marjie, do you
50,
know?
52.
Okay.
So we still got a few to go. So we're really hoping everybody can come and we'll and I don't promise that there will be no snow, but we'll hope that there will be no snow by 3 weeks from today. So
Do the
yeah,
best you can, Lauri.
yeah, for sure. Yeah. Thanks, everybody.
This is a plug for Chris Gainor. We have the AGM coming up next week.
Yes.
It's virtual. It starts at 7 p.m. and it would be great to have everybody out because we do need to have a large representation for membership.
We need a large crowd out to liberate me from being president.
Yes.
Oh, that was the motivation.
Yeah,
That's it. Yeah.
I actually do have a couple of little space items here.
Yeah, go ahead, please, Chris.
So just a minute. Where's the share thingy? Okay. A couple of interesting things. I'm going to be very brief, but you know, a year and a half ago now, or fall of 2023, OSIRIS-REx returned to Earth with quite a haul of soil from the asteroid Bennu. And the first results from that are being published. And they are finding some of the building blocks of life. I think it was 14 of 20 different amino acids that are necessary. And so it's these sorts of things have been found in meteorites that have come down, but of course, often you know, they've been exposed to the Earth, and they've been lying around Earth for thousands of years, and this is a fresh, pristine thing. So this kind of heightens the idea that there's life out there, but it's still a couple of steps from finding that. So I urge you to go to look at that and read up on it.
Chris, wasn't there an Andromeda Strain movie about 40 years ago where they opened it up and there was actually a live virus that started a...
That's right. That's right. You know, it was kind of a different version of, you know, War of the Worlds or something like that. And the other thing I'm going to mention here, and I just got this in my emails today, and I've been running around, so I haven't been able to follow it up. But I got this, and just to read the text here about these two missions, neither of which I'd heard of before today. You know, there's all sorts of weird and wonderful spacecraft being launched for very, you know, kind of obscure but interesting missions. You know, one is looking at the sun, and you know, the other one is is doing a spectral survey. So anyway, these will be going up towards the end of the month, and so keep an eye out for that, and we'll see what they do. So that's basically what I had to say. You know, I also was in the Southern Hemisphere once. It was 50 years ago. I think both Joe and I went down to Fiji in the early 70s, and you know, on different occasions, but it was a similar time. And my favorite memory of that is that I took a plane from Vancouver down to Tahiti on my way to Fiji, and it just went south, and it was at night, close to New Year's, and I looked out my window, and there was Orion standing up, and I watched it for, you know, it was about a 10-hour flight, and it just tilted. You know, by the time we got to Tahiti, it was in a different orientation. That was neat. Seeing the Magellanic Clouds was neat. The big letdown was that was the winter we were supposed to see Comet Kahutek. And going to Fiji, back then, it was kind of like being at the edge of the world. So I was looking for Comet Kahutek with a little telescope I took with me, and I couldn't find it. And it took some time for me to figure out that, you know, everybody was skunked with that one. So that's my Southern Hemisphere recollection.
Well, I'm glad to hear I'm not the only one who observes stars through aircraft windows.
Interesting. Thanks, Chris. Is there anything else anybody else wants to bring up tonight? It's been really interesting discussions. Well, it's 9 o'clock, so I'm going to end the Astro Cafe for tonight. See people at the AGM next week. Take care of everyone. Have a pleasant week.